Right, 2020, paper 2, question 5, so a bit of probability here. So two events are A and B, so just the probability of A is 3/4 and the probability of A intersection B is 1/2. Find B. Now that line there means given that it's conditional probability. So you must remember a formula for conditional probability. Conditional probability is the probability that B intersection A over the probability of the second one, probability A. So probability that the event B occurs given that. Key word there if you ever see it in English version, given that it's conditional probability. So B intersection A is the same as A intersection B, still that region. And then we have the probability of A, so it's 1/2 over the probability of A, which is 3/4. Fire that in your calculator. You get 2/3, 0.67, but it does say give it a fraction in the simplest form, so 2/3. Lovely. But again, if you don't know that formula, disaster. Same as this one, but down the bottom, two of the easiest formulas to remember. They're not in your formula book. Here, A and B are independent. And I showed they're independent. Probability of A times the probability of B is the probability of A intersection B. And we know the probability of A is 3/4. We know the probability of B. No, we don't. We're going to have to work that out. And the probability of A intersection B is 1/2. So maybe if we draw a wee picture, so let's see. The probability of A is 3/4. Probability of A intersection B is 1/2. So 1/2's in there. The full circle of A has 3/4. 3/4, 0.75. It's a quarter, or 0.25. To work out the probability of B. Oh yeah, we could add them up. A union B there is 11/12. So if we've added up all these inside the circle, it should give us 11/12. So I'm going to write that 11/12 minus 0.25 plus 0.5. That's our probability of B. So A union B, remember, two circles together. So all of that adds up to 11/12. So add these two up, take it away from that. So 0.25 plus 1/2 and 11/12 minus that answer is 1/6. So now we can fire in 1/6 for the probability of B. And if we times these together, is it the same as 1/2? 3 over. Oh, sorry. Jeez, I made an awful wee silly mistake there. Probability of B, that was B only. To work out the probability of B, it's 1/6 plus 1/2. 1/6 plus 1/2, which is 6, which is 2/3. Throw it in your calculator. So times those together. 2/3, and you do get 1/2. 1/2 is equal to 1/2. Conclusion: the events are independent. So if it was 1/2 equals to 1/4, they're not independent, because that's not true. The events are independent. Next one. So it's a wee bit more foot-three. A spinner consists of 4 segments, as shown. Each segment is equally likely to land on. Liam, Circa and Lee played the game in which the spinner spun twice and the numbers landed are added together. The result is divided by 3. Just picking out the key points, see how you go, and the remainder is recorded. If the remainder is 0, Liam wins. Let's see, remainder is 0, Liam. Remainder is 1, Circa. Remainder is 2, Leroy wins. Is this a fair game? Justify your answer by relative calculations. I'm thinking here probably the easiest way to do it is a tree diagram. A tree diagram might be nice because it's only 2 events. So like, let's say here, the first one, say our spin 1. what can we get if we spin it once? Let's see there. Mightn't look too great. So we can get a 1, 2, or 3. Now fill your probabilities on the branches. The probability of getting 1 is 2 out of 4, which is the same as a half. Probability of getting 2 is 1 out of 4. The probability of getting 3 is 1 out of 4. If we go to spin 2, what can we get? Again, we can get a 1, we can get a 2, we can get a 3. Same down here, if we get a 2 in the first one, we can get a 1 in the second, 2 in the third, 3, or 1, 2, 3. Again, fill in your probabilities on the branches. The probability of getting 1 is a half, a quarter, half, a quarter, a half, a quarter. Now there they say the scores are added together. Actually, I might just do the probability. No, scores are added together, so scores are total. Let's see, so we get a 1 and a 1, we get a 2. Get a 1 and a 2, we get a 3. We get 1 and a 3, we get a 4. Down here, 2 and a 1, we get a 3. 2 and a 2, we get a 4. 2 and a 3, we get a 5. So all this is building up the marks. Down here, 3 and a 1, we get a 4. 3 and a 2, we get a 5. 3 and a 3, we get a 6. And the key thing here is the remainder is recorded. So 3 doesn't go into 2, so the remainder is 2. 3 into 3 goes once, so the remainder is 0. Next one, 3 into 4 goes once with 1 left over. 3 into 3 goes once, 0 left over, 1 left over, 2, 1, 2, 3. And then the probability of these, now you're probably not supposed to write outside the lines, but are relevant for Christmas. So just multiply along the branches. Half times a half. You can fill this in here actually as well. Half times a half is your quarter. Here. A half times a quarter. Fire it in your calculator. It's an eighth. And then a half times a quarter again. That's your eighth. That's the first 3 done. Next one. Quarter times a half. It's an eighth. Quarter times a quarter is 16th. Quarter times a quarter, it's another 16th. Down here, a quarter times a half is an eighth. Quarter times a quarter is a 16th. And a quarter times a quarter is a 16th. So let's see who wins what. So the probability of Liam winning. Now in order for Liam to win, what does it tell me? The remainder is 0. Liam wins. So Liam wins here, here. Is that the 2 cases? Oh, right. And this one here, the remainder 3, which is 0 as well. So Liam wins in them 3 instances there. So what have we got? An eighth, or how do you say or in maths? You add it together. Plus an eighth, plus a 16th. Throw it in your calculator, you get 2 16ths plus 2 16ths plus 1 16th, 5 over 16 chance of Liam winning. Now, we can see now the game's not fair. It's out of 16th, that means 10 out of 16th must be between the 2. So, this doesn't work. So if we go on, we look at Sarker winning. Sorka, she does it, the remainder is equal to 1. So the remainder is equal to 1 here, here, here. So if you go in here, 1 over 8, or, how do you say or? It's a plus sign. There, 1 over 16th, or there, 1 over 8th. So the same thing again, you get 5 out of 16, so that's 10 out of 16th. So that must mean, we can check it out, Lee winning, he has the greatest chance of winning. He has 6 out of 16 chances of winning. So again, we can have a wee look there at Lee. Here we are here, a quarter, 16th, and a 16th. Tally those up, which gives us 6 out of 16. If you want to simplify that down, 3/8. You know, so is the game fair? No. As Lee has the greatest chance of winning, or you could say the probability of each winning isn't the same. Right.